In the previous video, you saw two methods for how we might choose between competing hypotheses. In the second method, we asked the question, if the null hypothesis is true, what is the probability of obtaining the statistic we observed in our data, or one more extreme in favor of the alternative hypothesis? This probability is what is called a p-value. Finding the p-value involves a mix of ideas that you've learned about: sampling distributions and conditional probability. Imagine we have a null that a population mean is equal to 0. Then we collect sample data, and we find the sample mean to be 5, and the sample standard deviation to be 2. Assuming the sampling distribution of your statistic follows the null hypothesis, what is the probability of observing the actual value of the statistic from your data in this distribution? If we want to know the probability that the population mean is actually greater than 0, you could update the hypotheses. Values like 6, 7, 10 all fall out here and are even more of an indication that the alternative is true, that our population mean is greater than 0. Additionally, what is the probability you observe something even more in favor of the alternative hypothesis? This shaded region here provides that probability, the p-value. Notice the p-value is dependent on your alternative hypothesis, as it determines what is considered more extreme. If your alternative hypothesis is that your parameter is greater than 0, then we shade greater than the statistic, as shown here. However, if we change our null and alternative to look like this, then we shade to the left of our statistic. Our shading for the p-value would now look like this. Notice that this would create a very large probability in this case, as almost the entire distribution is shaded. And if you have a not equal sign in the alternative, then your shading is associated with extremes that are just far from the null in either direction. In these cases, we just care about statistics that are far from the null in either direction. So we end up marking on both sides and shading away from the null hypothesis to find our p-value. This often takes people a while to wrap their heads around, and there are two parts to understand. First, you have to fully conceptualize the definition of a p-value, which is the conditional probability of your data given that the null hypothesis is true. Then you need to figure out what to compute, which is visually summarized by these three images. You will get some practice with both of these before moving on and applying the ideas of a p-value to make decisions.